So, section 8.5, testing claims about the mean when sigma is not known. This is actually the more common case that you would not know the standard deviation for the whole population. Usually we just know the sample standard deviation S, and in that case we use the t-distribution or table A3 for the critical values. So for an example, I wanted to know for the students that succeed in pre-calculus, how long had it been since their last math class? My thinking was if students have a long gap between math classes, especially with something like pre-calculus where algebra is very important, well, if they have a long gap, then most likely they are not going to be as successful as those with smaller gaps. So, particularly, I looked at those that had earned an A or a B. And then I claim that they have less than one semester between math classes. So maybe it was 0 semesters, maybe just 1 semester. Let's see. So my information was based on 40 students that got either an A or B in my pre-calculus classes. They had an average of 0.725 semesters between the previous math class and this math class. And there's the S. So the claim is that the mean is less than 1, makes it a left-tailed test, and of course H sub O has equals. Since the level of confidence wasn't mentioned, then we're going to use 0.05. So the picture would look like this. With the t-distribution, we need degrees of freedom. That's going to be 39. And then we need 0.05 for the left tail. So now, look at table A3. We would need degrees of freedom 39, which is right here. And then, since it's one tail and 0.05, we're going to use this column right here. So if you go down to degrees of freedom 39, it's going to be 1.685. Negative since it's on the left side. Okay, we're done with the table. Now, use the calculator. This is a t-test since we've got S for our standard deviation. And when you go to t-test, notice that right here, it's going to ask for the S, not the sigma. So type in the sample information, put it as a left-tailed test, and then calculate. It turns out that the test statistic is negative 2.492, which definitely goes way to the left. It makes it past 1.685. And so we actually did prove something. So we would say reject H sub O. Whoever said it's equal to 1 is incorrect. And since this lands to the left, whoever said it's less than 1 is correct. So actually it's more like approximately 3/4 of a semester on average gap between math classes for those that get an A or a B. So the claim is true. There's not that much of a gap. And FYI, for those people that got a C or worse, from what I remember, it was an average of about 1.4 semesters, so almost double the gap. So that's a big predictor in passing math classes. Okay, something else that might interest you. Movies that are rated PG or R, so in other words, the more violent, the more risque movies, do they last longer than the kids' movies? I would think so, because most likely kids have shorter attention span, but let's see. So we've got the average amount of time at 118.9 for the kids' movies, PG or G. Maybe I shouldn't say kids' movies, because I like G-rated movies going with my son. Anyway, enough about me. So anyway, test the claim that these other movies are going to last longer than that. So I found 19 big budget films. So you can easily do this online. You just Google. You can find out how much money it takes, how it takes to make the movies, how many minutes they were, how much money they brought in the first weekend, how much money they brought in, etc., etc. You can find out lots of information. So this is what I found. So they averaged 141 minutes. With this S, again, since it's only based on 19 movies, S equals 28.9. So the claim is that it's longer than 118.9. That's going to make it a right-tailed test. Once again, I didn't mention to use what level of confidence to use, so we're going to use 95%, so alpha equals 0.05. That goes in the right tail. I write down the sample information to make sure I've got all of that correct. Yes. So it's going to be a right-tailed test. Sorry about my pen acting a little crazy right there. Degrees of freedom is n-1. And again, we use table A2. So again, it's one tail with 0.05. Go down to where degrees of freedom is 18. And that's going to be 1734. Okay, done with the table. Now time for the calculator. So it's going to be a t-test. Type in the sample data. So, whoops, that's a little too fast there, buddy. So type in the claim, number from the claim, the sample data. Make this a right-tailed test. And so it turns out that t is a 3.379. If you were to use the p-value, this is extremely small, and since it's less than 5%, we can reject and make a conclusion. Or you can use the critical value method. 3.3 definitely goes past 1.7, so we actually did prove something. So reject h sub o, which is saying reject this equals sign, and you can see from the sample data this is way bigger than 118. Or you can look at this, say this is pointing to the right, so whoever said this should be pointing to the right is correct. So it turns out that the movies that are more adult geared, the PG-13 or R, they are longer than the kids' movies. Okay, now, remember confidence intervals? We haven't done those for a while. Let's go do that same problem with confidence intervals. So there was 19 of the PG-13 and R movies, so there's the sample data again. And then use a confidence interval. So as you may remember, even though it's an interval, it's listed under tests first of all, and then you go down to t-interval, type in the sample data. This time there is no 118 to type in because there is no claim, so we're just using the sample data only. And then create the interval. So this is saying for movies that are PG-13 or R, they last somewhere on average between 127 and 155 minutes. Now consider those G and PG movies, they averaged 118.9. So does that even land between these two numbers? 118 does not land between 127 and 155. So that is then showing that the PG-13 and R-rated movies, these right here, do last longer than the G and PG movies. So this is another way to sort of verify what we did with the hypothesis testing. And we're going to be doing this in the next chapter, so that's why I want to sort of remind you of confidence intervals right now. So again, the conclusion is that those geared for older people do last longer. All right, I'll see you in the next section, which is going to be the end of chapter 8. Bye.